This is the video recording for example 8.6. So here in example 8.6, we are given the weight of the block, the spring constant, and the forcing function. So similar to example 8.5, we are still under the assumption of negligible damping or no damping at all. The weight is initially displayed 6 inches above equilibrium and given an upward velocity of 2 feet per second. We are again asked to find the displacement y of t for t greater than 0. So similar to 8.5, we just collect the given information and then try to write the ODE associated to this problem. So let's start. The weight is given to be 64 pounds. So it follows that we can compute for the mass as weight is equal to mg. So m is just equal to 2. And then the spring constant is already given. Unlike in example 8.5, we computed for the spring constant using the principle of statics. And then the forcing function, okay, this will define whether we have later, no? This will define whether we have a resonant or non-resonant case depending on the relationship between the natural frequency of the spring mass and the frequency of the forcing function. And then the initial conditions are given on the second statement. So the weight is initially displaced by 6 inches above the equilibrium position. So in that case, y at 0 is 6 inches above, so it's negative. Our sign convention for vertical spring mass systems, positive yung downwards. And then we convert this to feet, so we have 1/2 of a foot. And then the velocity is also given and it's upward. So hindi na siya released from rest. So in this case, we have 2 feet per second. Again, upward. So consistent with our sign convention, it should be negative. Okay, so based on this given, we write the ODE for the spring mass system. We have my double prime plus cy prime plus ky is equal to f of t. Again, the problem is silent about the nature of damping, so it's basically 0. M is given, so we have 2y double prime plus k times y is equal to 2 sine t. So this is our ODE. So isosolve na lang natin to using the principles, whether isolve na siya as an ordinary differential equation or applying the principle of a spring mass system. So here, we already know what will happen in this problem. So meron tayong free damping, o diba, kung no damping pala, sorry. Meron tayong no damping case, isa lang naman yung solution nun, yung combination ng sine and cosine. So for no damping case, we have yc is equal to a cosine omega t plus b sine omega t. And then basically, it will just call for the calculation of the natural frequency, which is square root of k over m. So square root of 4 is 2. So our solution to the homogeneous case, assuming free oscillation pa, wala pa tong contribution, kaya siya yc, is a cosine 2t plus b sine 2t. Then after this, we characterize, kasi in preparation for YP, we now characterize the nature of resonance, yung resonance condition. So in this case, since the natural frequency is not equal to the frequency of the oscillating function, then we say that we have a non-resonant condition. So, na-discuss naman ito sa lecture number 8. So, what we can do at this point is to check, okay, ano ba yung available solution for us for non-resonant oscillation, where the natural frequency is different from the frequency of the oscillating function. So similar to example 8.5, we already have a derived formula. However, knowing yung concept na this one is actually derived from MUC. So itong particular solution na to, U sub P, is dependent on the nature of the function on the right side of our equation. So halos magkaparehas yung 8.5 in a sense and 8.6 in a sense na yung example natin or yung derivation natin came from a function which is a cosine. Dun sa example 8.6, sine function kasi ang nasa right side. So therefore, hindi natin pwedeng directly ma-apply itong particular solution nito. So ano yung solution natin? So how are we going to solve the problem? Eh di babalik tayo dun sa derivation nito, which is MUC. So going back to our problem, okay, going back, so since this one is a sine function and the available to us via lecture 8 is based on the cosine function, so we cannot directly apply the formula in the slide. So what we are going to do is to simply apply MUC. So in this case, we recall the MUC sets up YP based on the linearly independent functions coming from the right side of the equation. So in this case, we are looking for sine t. So the finite family of functions are, of course, cosine t and sine t. So our YP will be C sine t plus D cosine t. Or, of course, pwede namang magpalit yung order niyan. And then, what we're going to do is to get YP prime and YP double prime and substitute our OD. So YP prime is C cosine t minus D sine t. And then YP double prime is negative C sine t minus D cosine t. Then we substitute, so we have 2y double prime, so negative C sine t minus D cosine t. Then plus 8yp C sine t plus D cosine t is equal to 2 sine t. So that's it. And then after that, we compare like terms. So as you can see, hindi na natin ginawa yung checking with YC kasi technically, ginawa na natin yun kanina, kaya nga natin na-conclude na non-resonant condition. But to complete yung MUC, diba, trial muna ito and then we compare it with YC and then kung meron duplication, we multiply YP with the lowest power of T to remove the duplication. So anyway, going back, so we compare like terms. So we gather all the coefficients of sine t on the left and the right. So we have negative 2c plus 8c is equal to 2. Okay, so we have 6c is equal to 2. So c is equal to 1/3. And then for cosine t, we have negative 2d plus 8d is equal to 0. So 6d is 0. So d is equal to 0. So it follows that our YP is 1/3 sine t. Okay. Then after that, we combine yung YC natin tsaka yung YP. So our solution, y is equal to yc plus yp. So y is equal to a cosine 2t plus b sine 2t. Is that consistent? Let's check. Yeah, cosine and then sine, and then plus 1/3 sine t. Okay? Yung initial condition natin, sabi natin sa problem, y at 0 is -6 inches, 6 inches upward, so that's -1/2. And then y prime at 0 is given to be 2 feet per second na upwards then, so that's -2. Sorry. So in this case, we can use the first condition. At t equals 0, y is -1/2. So we have -1/2 is equal to a cosine 0 is 1, plus b sine 0 is 0, plus 1/3 sine 0 is 0. So a is equal to -1/2. And then for y prime, we have -2a sine 2t plus 2b cosine 2t plus 1/3 cosine t. So here, y prime at 0 is -2, -2a sine 0 is 0, plus 2b cosine 0 is 1, plus 1/3. So solving for b, we have -2 minus 1/3 divided by, so that's -7/3, divided by 2, we have -7/6. Okay, so finally, we write the solution. Y at t will be equal to a, -1/2, cosine 2t, plus b, -7/6, sine 2t, plus 1/3 sine t. So, ito yung hinahanap sa problem natin. But para mas ma-interpret natin yan, of course, we are very free to plot this function in the available platforms or substitute specific values of t para ma-interpret natin at this time, nasa taas siya ng equilibrium position. At this time interval naman, nasa baba siya kasi nga oscillation yung function niya. And basically, that's it. So yun lang, pag magsa-substitute lang kayo ng time dito sa ating solution, you have to make sure pag gagamit kayo ng inyong calculator, you have to set it in radians. Kasi yung tinatanggap na argument dito ng cosine and sine functions are in radians.